how is it that we get to know a lot of this information? Well, y'all already know that I love to see stuff that gets taken pictures of in my body. Okay? So imaging. Love it. We have radiography, which is X-ray. Any of y'all going into any imaging or anything? No? Okay. Ultrasound, CAT scans. Y'all heard of these? Anybody had these? Like a MRI or what'd you have?
Oh, I've had an MRI and CT, but I work in an OR.
Cool.
Yeah, MRI, CT, ultrasound, X-rays.
Hey, that's me too.
X-ray, ultrasound, CT, and MRI.
Yeah. And it's really cool because if you've had like some of each, like if you've had the X-ray, had the CAT scan, had the MRI, this sort of thing, you actually get to see how the visuals that are taken are different. And it is really cool, okay? Can't imagine what you get to see in an OR. I think I would like that. Yeah. So, I'd be like, oh, yippee, what are we cutting today?
It's kind of like the image you go to the cath lab, they hook you up and you put the dye in.
The dye in.
And you actually see the heart pump.
I know, cool, right?
The fluoroscopy and the OR when you get cortisone shots.
I know, right? So, it's just like really cool having all these visuals that we can go to. PET scans. Now, PET scans, to me, those are extremely interesting, okay, because of how they actually do PET scans, what actually has to occur. X-ray, of course, is the oldest one that we have. It was discovered first. It basically what it shows you, the hardened tissue of the body. So that shows you the bone. You don't get a visual of the softer tissues, okay? Because the one thing that it shows is simply the hardened tissues, which are going to be the bones. Now, ultrasound. And ultrasound has definitely come a very long way. They do ultrasound techniques in lots of different places around on the body now. They do it for the heart. They do it for the gallbladder. They do it for the liver. They do it for the bladder. They can do it on the vessels of the body to view the blood flow. I mean, it is just really pretty cool. And they have really come a long way that you truly get your first picture of your baby in utero with these ultrasounds that they're now doing. The CT scans are, we're definitely seeing the hardened tissue because we get to see bone, and we're seeing soft tissue, which in this particular image is the brain. So we're getting different visuals of the tissues of the body. Now, this 3D reconstruction, I'm sure that is something that's just continuing to take off with all the technology that we have now, but it's the actual view of a part of the body. Angiography, actual blood vessels, meaning they can see the actual blood flow of it through the body, which I think is pretty amazing. The MRIs based on the magnets, okay? And this is giving us very good visuals of soft tissues, or maybe I should say softer tissues of the body. The PET scans. With a PET scan, these are usually the scans of last choice, mainly because, insurances do not like to pay for these to be done. They're very expensive. Usually, when they're done, people are already in advanced states of their diseases. And what I find really interesting, they use a radioactive labeled glucose. Now, that brings me to an interesting question. Why glucose?
Because the body feeds off the glucose, all the cells do.
It's going to give you an idea of where everything's getting metabolized and where the energy is getting allocated.
Focused. Yeah. Glucose. Sugar. All right? It is the simplest sugar that the body can take up. And it is the sugar. It's actually the only nutrient the brain uses. The brain has to have glucose. So, it is a molecule that if they radioactively tag it, and when we get glucose into the cells, what do we use it for?
Energy.
It's to get it, and what process generates energy? Okay, let's think back a minute or two into general bio. What organelle in the cell can use the glucose? The mitochondria. The mitochondria carry out what process to make energy? And what is energy in the form of? It's in the form of ATP. What is the process called that generates ATP? Okay, one of those cycles. But you're on the right track. Well, now the Calvin cycle is going to be in the plants, but the Krebs cycle, okay, is going to be in the animal cells. And that's in what process? Does anybody remember? Does cellular respiration ring a bell?
Yes.
Yes. Now, what they learn from that, if they have that glucose that is radioactively tagged, meaning it's going to shine nice and pretty. It's going to have all these different colors on there, like the blue, okay? That lets them know that those cells right there are active. Because cancer cells, which is usually why the PET scan is being used, okay? Cancer cells never stop. They never stop duplicating, they never stop replicating. They do not stop. So they would be very metabolically active and therefore would take up a lot of glucose. So if that's the case, all of that radioactive glucose would go to that area of the cells, and that's where they would see the cancer. Now, is that not the coolest thing ever? I don't ever want to have a PET scan. You know, now would I like to have one based on just for fun? Oh yeah, okay. But hey, insurance is not going to pay for that, and I'm not either. So these imaging techniques, however, we've learned a lot, and they have actually, I am shocked at how far we have come with the imaging techniques. But another way that we actually learn about cells, and the body as a whole is with surgery. When you're in the surgery, in the OR, okay? Now, a lot of things now, still, so much has gone to like being laparoscopic, okay? A lot of it has. But do they ever do cuts anymore? Do they still?
Oh, yeah.
Yeah, they still do the cutting?
Oh, yeah.
Okay. Is a lot of it going to robotics now?
Not, yeah, not really. There's
Not-
still a lot of old surgery.
Okay, a lot
Because
that's
a
still
lot of
being done by
times-
hand.
Yeah, a lot of it is still, it's more beneficial to do it open than it is to do robotic. Like anything that they can do robotically, they do, definitely, because the healing time is quicker.
Mm-hmm.
But there are still, like spinals, they have to do that open, trying to think. Most of our trauma stuff is done open.
Okay.
A lot of ortho is open.
Yeah, tell me about that.
Yeah.
Yeah.
Stuff is still open.
So, this is another way that we get to see and learn a lot about the body, is when it's cut open and they look around. You know, they go in and they just simply look around. So that's one of the other ways that we learn a lot about the human body. Now remember, the way that our textbook is going to move information along for us, it's going to take us from the smallest component up to these organ systems making up this organism that we are. So, in thinking about this hierarchy that's involved, we're going to start at this lowest level, chemical. Now, I shouldn't say lowest, smallest, okay? The smallest level that we have. Chemistry. What comes to mind? The elements.
Periodic table.
The periodic table. Oh, yay. Okay. However, one thing I do want to point out, because I love chemistry. I do. I might understand this much of it, okay, but I love it. When we think about chemistry, this chemical basis of life, that periodic table is hopefully going to come to mind. Something like that, right? Okay? And when we begin to look at it, over here, we're going to have what's termed metals. These are our transition metals. These are going to be non-metals. And then finally, our noble gases. Down here, a lot of the lanthanide series and stuff like that. When we talk about anything that we can see, all right, anything we can touch, all right, that we can feel that is making something up, this is chemistry. This is chemistry in action, all right? Matter occupies space and has mass. Mass, what is the amount of matter? And then the weight. What's the difference in mass and weight?
Mass is the amount of weight is how much something weighs. Mass is how big the object is.
Well,
Like, matter is more about like the amount of molecules and like the weight of the molecules in like a certain object, and then weight is more like the gravitational force. Yeah.
yes. Because we have all these chemicals that are making things up. Those chemicals have a mass. But weight is what is the gravitational force. From the time you get up out of bed until the time you go back to bed, you are under the weight of gravity here on our planet. Oh my gosh, got the weight of the world on my shoulder. Literally you do. Because you're under our gravitational force. But if I were to go to another planet, that gravitational force would be different. My weight would be different. I would love it if I weighed what it says I weigh on Pluto. Okay? But this gravitational force is what it is. For us as humans, the gravitational force we have to deal with, how's it going to affect our bodies?
Stress on everything. There's pressure on every part of the body.
All right, we're going to have a pressure on every single joint of the body. From the time you get up till the time you go to bed, you're going to be shorter when you go to bed than when you woke up because of the gravity pushing on you. Can you think of any other functions of the body that gravity might affect? Okay, the blood moving through the veins, the heart pumping, breathing, digestion, urination, defecation. I know, right? I'll tell y'all a little secret. Ever heard of zero gravity? What is it?
It costs a vacuum.
Supposed to be like this state where we're not supposed to have like any of these pressures on our body.
Isn't it like when you're at like weightless? Because like I know astronauts when they come down to bone masses, they're less dense than
They're
they were
less
before.
dense because they haven't had the gravitational pull working against them. Yes. So I'll tell you all a little secret. I'm really excited, because when I go home, it's going to be new. It's hopefully going to be there when I get home this evening. I got a bed coming that's going to have the ability to do zero gravity. And I can't wait. I'm like, I'm going to go home and see, I hope when I finish class today and I call my hubby and he's going to be like, yay, they're here, they're putting it up. So, the force. The reason I mention this is because of the different areas it affects of the body. Now, for our purposes right now, in this chapter, it affects weight of matter. So when we begin to look at the periodic table, the elements and the atoms,